Are you ready? The areas of circles and sectors. Guys, so saw my mom this weekend, and she's like, I saw Grandma Bateman. I was like, oh, you did? I haven't seen her forever. How's she doing? She's like, good. And she's like, she wants to see your classroom now. And I was like, what do you mean now? She's like, well, I told her that you told your kid about the pool, and now she wants to come visit. So maybe one day, guest speaker Grandma Bateman will come in. I don't know what she'll do, but she'll just come and sing and be loud for you. She's so fantastic. Okay.
Does she see oh wait, does she teach math too?
No. She was a cheerleader and then a mom. That's it. But she's also been in tons of plays. She's just like, I don't know how to explain Grandma Bateman. You just gotta meet her. Okay. Yes. Here we go. In the Grandma Bateman story, we've been talking about circumference. Today we're talking about areas. But backtrack. What's circumference in the Grandma Bateman story? Say it again. Say it again. You really got to get that down in your head. Area is what in the story? Say it again. Wait. That makes me nervous. It's specific. It's not just the pool. It's
area inside.
I would say the cover, because that covers the pool completely, right? Exactly. The entire pool would be volume as long as it's full to the top with water, right? Okay, so circumference is the fins, area is the pool cover. Today we're doing area of circles. Now this next part, don't we just have one vocab word?
Yeah.
What's the word?
Sector of a circle.
All right, sector of a circle. Some of you have the hardest time not copying stuff down, so I'm going to hide it. Don't do that one. While you're waiting for me, draw a circle. I'll just use this. Okay, you've got your circle on there. Don't worry about putting this next part down, just watch. If I eyeballed the center, like right there, and I had a central angle coming off, right there, the squiggly. What's the vocab word for the squiggly? Arc. I heard it over here. Arc. Yes! That's a good job. That's arc length. Today we're not talking about length though, we're talking about this word. What's this word? This is what a sector is. Are you ready to draw? It's all of it. It's a slice of the circle. Yep, like a piece of pie or a piece of pizza. Sector. It's literally you cut that part out and you measure it. How big is it? You're going to find the area of it. Easy enough? So you make sure you're talking yourself through the difference between arc length, just a piece of the edge, it's like the crust. Yeah? And then sector is the entire piece of pizza. Good enough? Okay, well, next, area formula. Do you remember it? Pi r squared. Write it down, write it down. We're actually doing this in the 7th grade classes, pi r squared. What do you think the most common mistake is with this formula? Timesing it by 2. It's not times by 2. What is it? Square. What does square mean, though? There you go. Pi times r times r. I have a question for you. R squared, r times r. Actually, let's get into it. Example. Find the area of, question, what does this mean right here? Alright, this is kind of weird symbol, right? The area of circle P. What's the radius in the picture? 14. Let's put our answers in terms of pi and a decimal. So our formula is A equals pi r squared. You just said the r is 14. So grab your calculators and just type in 14 squared. How many of you are using the square button? Did you know there's such a thing? Feel free to use it. Alright, what's 14 squared? 196. Okay, let's put that for part of our answer. 196 square centimeters. But then let's also put a decimal answer. Oh, what am I forgetting? Oh, that's a big deal, right? 196 pi square centimeters. Alright, now grab your calculators. Type in 196 pi. Let's get a decimal equivalent. 615.8? Alright, centimeters squared. Okay, another thing that I've been coaching my little 7th graders through. I love it when their 8th grade teachers come and like, how do your kids know this? It's like my favorite thing. So I've been telling them why it's centimeters squared. I've been practicing. Did you guys know why it's centimeters squared? Okay, nobody? Geometry students, we don't know this? It's not too bad. Are you ready?
Is it
So-
gonna be, like, capitalized there?
No, not necessarily. This is what you're doing. Let me change up the color. So back to this part right here. You're doing area equals pi times, I'm going to write it out, 14 times what? Yeah. Well, 14, what units on the 14? Right? And this one's still centimeters? So check it. Centimeters times centimeters is
Oh, yeah.
centimeters squared. That's it.
Oh, I thought it was also we because we measured area in like little squares and
Yeah.
then centimeter by centimeter.
Yeah, that would work. Ellie said measuring in squares, centimeter by centimeter. Yep, but nitty gritty, easiest answer, that's why. It's like centimeters is a variable. Variable times itself is that variable squared, centimeter squared. How many of you nod your heads? I get that. Makes sense? Not as tricky as you might think. Okay, letter B, you gotta go backwards. Find the diameter of circle Q. Okay, let's take what we know in the formula. So area equals pi r squared. So we've got 125 equals pi r squared. Okay, what do you want to do first? Sure. Let's divide by pi. So take 125 divided by pi. It's got to be a decimal. Doesn't mean you have a decimal. 39.8. So now we have 39.8 equals r squared. Now what? Perfect. Square root it. What is it, Garrison? 6.3 inches. What do you think? Are we done? It's tricking you. Go back up there, careful. What is it asking for? Is it asking for radius?
No, that's for the diameter.
Diameter. So what do we have to do?
Times
Times it by 2, yeah? Double it. Easy enough to double. Guys, what's the diameter? Huh? Yeah. 12.6. Do we need to put inches squared on this one?
No.
That's just diameter. How many? I got that. You okay with those ones? Aaron, not too bad? Okay. You're on your own. Go for it. Here we go. Let's go through the first one. We've got our a equals pi r squared, right? What's r in the picture? So that would just be a equals pi times 3 squared. Guys, what's 3 squared? How many of you left it in terms of pi? Perfect. If you did both, even better. Might as well practice, right? So CRT, you're not like, what the? I don't remember. Grab your calculators. 9 times pi. Or raise your hand. Will you help me? I'll get confused if you all shout out. What did you get on this one?
28.3.
Caitlin, what is it?
28.3
28.3.
inches squared.
Thanks for saying it just squared. How many of you? Yeah, I got that. You okay with that? Okay, next one, area. Don't be tricked. What's the trick just looking at the picture?
You have to divide by 2.
Divided by 2, right? It's the diameter, so it's 25 divided by 2.
12.5.
Nice. So use 12.5. So this one we've got area is pi times 12.5 squared. Just type in 12.5 squared. Okay, what is 12.5 squared?
156.25.
0.25? Alright, we've got 156.25 pi feet squared. Or, okay, you ready? I'm going to call on a random person for the decimal, so get ready. What's 156.25 pi, but as a decimal? What's its decimal equivalent? Okay, Brett, do you have it? What is it?
490.87.
Thanks, Brett. 490.87 square feet. How many of you got one or both of those answers? You okay with that one? Nicely done. Okay, number 3, backwards for diameter. Oh, okay. So we've got 248 equals pi r squared. Guys, nice and that. What would you do first?
Divide by pi.
Nice. Divide by pi. Divide by pi. I'm going to need help. Did anybody show your work on this one? Or just grab it in your calculator real quick. Go ahead, Caitlin.
It's 78.9.
78.9 equals r squared. Again, nice and loud. What would you do now?
The square root of it.
Square root it. Whew. Somebody have the square root version? Keep going, Caitlin.
The radius is 8.9, and then you have to times that by 2.
Nice. Double that for diameter. What'd you get, Caitlin?
I got 17.8 millimeters.
Thanks for saying millimeters. Sneaking my answer. How we got the same as Caitlin on that one? Good? You okay with those? Okay, I think the next part is the big crunch for today, but it should look familiar. Oh yeah, it is. Alright, so sector, yeah? So we can use the sector formula. What you need to do right here is copy this one. That's what we're going to focus on, and it's very similar to what we've already been doing. So might as well use something, its background from something else. Does it look familiar? Kind of. We've got our angle over what? 360 times, check it. What we have been doing, for example, on the warm-up, right here was 2 pi r, right? What does 2 pi r stand for though? So that was circumference. And the circumference just gave us the arc length right here. But today we don't want the arc length, right? We want that whole so we go back. But what is that formula? That's why. So you times by circumference if you just want the piece. You times by area if you want the whole slice. Not too bad. You just gotta know when to use what. You might want to write that in there. In case you have one of those backwards problems and you just need to find the area. Just area formula of a circle. Okay.
Wait, I have a question.
Go ahead.
Oh, it's just a formula, because it's like area equals measure of angle AB over 360 times area, right?
Yeah, let's use it. Are you ready? First one is what's the angle in the central angle?
110.
Put it over what?
360.
Okay, 110 over 360. And then you gotta talk yourself through it. Are you trying to find a whole slice or just the crust? Whole slice. So if it's the whole slice times by the area formula, pi r squared. What's r in the picture though?
7.
Okay, I don't know if this will work out. Let's try terms of pi. So type in 7 squared, or just, what is 7 squared? Okay, type in 49 times this fraction. 49 times 110 divided by 360. I just don't know if it'll come out nice. Does it? Is it a whole number or is it a decimal? Like a long decimal? Let's not worry about it then. So take this and then times that by pi. We can just type it in as is. Okay, shout out, what'd you get?
47.
0.04? Thanks, Allie. Go ahead, Ellie. Oh, that's a times. 49 times. How many have you got? 47.04? You seem kind of hesitant. Okay, let's do another one. Make sure you're calm. Okay, number 4. Take that 54 and put it over what? And then, are you finding the crust or the slice? It's the slice of it, right? So times by pi r squared. But what's r in the picture? See it? So 5 squared. Grab your calculators. Be careful. Again, order of operations, you might want to put parentheses around your fraction. And then times it by pi. And times it by 25. Okay, will you check with the neighbor? Tell a neighbor what you got on this one. Alright, tell me, what'd you get?
11.8 units squared.
Alright, that's what I got too. What are we going to do for units though? Squared, right? Because it's asking for area. Okay, will you try number 5, number 6? Try them. Done? Okay, so number 4, I'm just going to show my work while you're finishing. Alright, can I get a hand in there? Tell me what you got for number 5. Alright, are you ready? Okay, Tanner, tell me what you got. Thanks for saying unit squared. Because raise your hand if you got the same as Tyler. Do we agree? Thanks, Tyler. Okay, next one, let me show my work. That's going to be a big section. So 288 over 360, it's a whole slice, so times by pi r squared. Alright, then we have this one. You mind helping me out? Go ahead, Kenan, what'd you get? 361.9 units squared. How many of you got that? How are you feeling okay about this? Doing okay? Just remember the difference between circumference and area. Okay, definitely gonna do the next problem. These are fantastic questions. And just be ready. Every year I've taught geometry, I've seen this type of question on the CRT. They're not too bad though, so let's walk ourselves through it. Okay, this one, you know, I kind of want to hide this. Feel free to write. Oh, so it's saying find the area of the shaded region. So we want everything except for this sector and that sector, right? Okay, what if the whole thing was filled in? Guys, what's the shape of this? How do you find the area of a rectangle? Base times height. Allie, thanks. Let's do that. So let's find the area of the entire thing. So the area of the rectangle is just going to be 12 times 8. All right, do you have that memorized? 12 times 8? Nice. 96 inches squared. Okay, stop and think about this. What if you get to this point? CRT, you're so tired, you've been working on the computers, and time's about up. You're just like, I don't remember how to do this. Just knowing that the area of the rectangle is 96, is that an advantage? Because if you look to your ABCD choices, would you want to go above 96 or below 96? Definitely below, right? Because it's got to be below 96, and then you can just estimate which one looks the best. So feel free to just do one thing, and hopefully that gives you a leg up. All right, I have an idea. What if we take the area of the whole thing, and we just subtract what we don't want? Would that work? So right now we know the whole thing is 96, and let's just find the area of these ones and subtract them. You okay with that logic? Do we know how to find the area of those ones? We just did it. It's the formula we learned today. Once we know one of them, is the other one going to be the same?
So couldn't we just
Sure.
times 108 in the beginning instead of
Try it. Why don't you try and see if it works? Okay, so let's take the 108 and divide it by what? Divide by 360. Times by pi r squared. All right, stop. You're going to have to figure out the r in this picture, though. What is it, Allie?
4.
How come? Can you back it up?
Because the circle is the same height as the rectangle, so you know the diameter would be 8. You divide that in half to find the radius of 4.
Nicely done, Allie. Thumbs up. How do you see that now? Do you see that? Radius would have to be 4. Okay, grab your calculators and just type it in. 108 divided by 360 times it by pi times it by 16. Okay, help us out. Hand in there. What did you get for the area of the sector? Landon, thanks. What did you get?
35.548 inches squared.
Nice. Okay, so what you just found is that sector, that entire thing. We need another one, so what are you going to do? Yep, just keep what's in your calculator and hit times by 2. Okay, shout out, what'd you get? 63? 60.3, got it. Alright, so that's 2 of them. You just found this and that.
Wait, second?
Yes.
I think the area just under the sectors is going to be 15. Yeah.
Oh, was the 35.8 already doubled? Oh, thank you for catching that. Let's go backwards. Okay, pause. Do this one again then. Let's double check ourselves. Do the 108 divided by 360 times by 16 pi. We're not agreeing with this 35.8. 15.1. And then we need to double that, right? So double that is now just 30.2. Okay, thank you for staying with us. Take this and one more step, what would you do? Yeah, take the area of the whole thing and subtract that piece. Subtract what we don't want. Perfect. Thanks for checking that, Ellie. Alright, so 96 minus that 30.2. Guys, nice and loud, what'd you get? Oh, did you notice it was right there the whole time? 65.84. How many of you got that? You good? How many feeling okay about that problem? Does the logic of it make sense? Okay, good, good, good.